Principles of Bioproduct Separation Module 2, Filtration and Microfiltration Segment 6. With me again, Yusuf from Institute Teknologi Bandung. Previously, we have discussed about equipment for filtration, pre-treatment methods, general theory for filtration, continuous rotary filter, and laboratory test. In this segment, we will discuss about microfiltration. One of the major obstacles in the filtration process is the formation of cake that causes pressure drop in conventional filtration. When the cake is compressible, the pressure drop is not even linearly related to the flow, which affects the filtration analysis and filter design. Filtration without a cake offers real advantages that can be achieved in a process called microfiltration. Figure in the right shows that filtration without the formation of cake can be achieved using a large cross flow tangential to the surface of the filter. At the same time, the flow normal to the filter is relatively small. The large ratio of cross flow to the flow through the filter minimizes the accumulation of cake. Microfiltration is used to concentrate insoluble. It is like ultrafiltration and is analyzed with similar equations, which will be discussed in detail in Module 11. In this segment, we will briefly explain about the filter itself, requirements for purging, and filter geometry to highlight comparison with conventional filtration. The key part of microfiltration is the filter medium itself, which is also known as a membrane that is thin and microporous. The pores are small and highly monodisperse as they must retain the particles being filtered, but quickly pass liquid and smaller solutes. As a result of small pores, the membrane has a low Darcy's permeability and a high resistance to flow. These features mean that a microfiltration membrane is different from a conventional filter medium. Such a conventional medium has a high Darcy's law of permeability, which indicates a low resistance to flow. Periodic purging is very important in the microfiltration process. Initially, the feed in microfiltration is a highly dilute suspension. As liquid is removed, the suspension becomes concentrated. Rapidly pumping this suspension, which is necessary to sustain cross flow, is increasingly difficult as its viscosity highly increases. As a result, the concentrated suspension must be discharged even when it contains much more liquid than that in a conventional filter cake. Hence, microfiltration may be followed by a conventional filtration or centrifugation to separate completely the insoluble from the solution. In microfiltration, the flow through the membrane is slower than the flow through a conventional filter cake. Since the flow per area is very low, microfilters are designed with a larger filter area per volume than conventional filters. There are three common designs. First, plate and frame. The shape is similar with the conventional filtration but contains a microfiltration membrane. It has a modest surface area per volume but do not often plug and easy to clean. Membrane failure can be easily located and replaced. Second, spiral wound module. It has a larger area per volume but plug more easily. The shape is like a large envelope filled with feed which is filtered through the envelope's wall. However, the envelope is loosely rolled and the filtrate is collected from the end of the roll. It is often discarded when part of the filter fails. Third, hollow fiber module. It has a larger area per volume but plug more easily. The shape is like a small shell and tube heat exchanger in which the tubes are microporous fiber membranes. The suspension being filtered flows down the fiber's interior. The fiber's lumen and filtrate is collected from the outside of the fibers on the shell side. It is often discarded when part of the filter fails. In order to get a better understanding about these modules, students are required to do examples from Belter et al. First, example 2.31, page 25. Second, example 2.32, page 27. Third, example 2.33, page 28. Fourth, example 2.41, page 34. You may want to check these videos in YouTube for a better visualization about filtration. In the next module, we will discuss about centrifugation. Until then, I am Yusuf from Institut Teknologi Bandung.